How can an expert let AI agent do more? Ownership stays clear. In June 2026, Anthropic published a privacy-preserving analysis of roughly 400,000 interactive Claude Code sessions from about 235,000 people, observed between October 2025 and April 2026. The pattern is not that experts micromanage every action. Stronger domain understanding is associated with longer action chains per instruction and a better ability to recover when the session goes wrong. This episode turns the findings into a responsibility card: who owns planning, what execution is delegated, which evidence verifies the result, and who takes over on failure. The card is our practical synthesis, not an Anthropic template. This video is packed with practical, high-value insights to help you get better at using AI. It is a longer one, so follow Tiny Agent and save it so you do not lose it. Start with the observed division of labor instead of treating autonomy as a single on or off setting. The study separates planning decisions from execution decisions. Planning covers what to do, which approach to take, and what counts as done. Execution covers files, code, tools, and commands. In a typical session, people make about 70% of planning decisions but only about 20% of execution decisions. The common pattern is simple: the person decides what to build, while the agent decides how to build it. That does not mean one prompt and a silent exit. A typical session has about 4 back-and-forth turns, each offering a chance to correct direction. Each user prompt triggers around 10 agent actions on average, and the distribution has a long tail. One check-in can therefore govern a substantial chain of work. The useful question is not how many steps the agent may take. It is which decisions must stay with the person who understands the problem. Chapter recap. First, separate what to do from how to execute it. Second, delegate verifiable execution without giving away the goal. Third, use staged check-ins to keep the direction correctable. Next, understand why expertise can expand the agent role instead of shrinking it. The study rates apparent task expertise on 5 levels using precise framing, requested verification, and who corrects whom. It is not a job title or a measure of general ability. A senior engineer can be a novice in an unfamiliar language. An accountant who defines reconciliation rules and catches a month-end edge case can be an expert for that task. In typical novice sessions, one prompt triggers about 5 agent actions and roughly 600 words of output. In typical expert sessions, the chain exceeds twice as many actions, around 12, and carries roughly 3,200 words, about 5 times the novice output. After controls for work mode, task value, month, occupation, and model family, each expertise level is still associated with about 9% more actions and 13% more output. More text is not automatically better. Precise constraints let the agent safely advance more checkable work before the next handoff. Chapter recap. First, expertise is specific to the task at hand. Second, precise constraints expand the agent's useful action chain. Third, judge progress by verifiable artifacts, not output length. Now divide responsibility by capability and uncertainty, not by drawing a simple human versus machine line. Stable, reversible, rule-bound execution can be delegated in batches: reading files, making mechanical edits, running checks, and collecting evidence. Goals, value conflicts, hidden constraints, and costly trade-offs stay with a person because they depend on domain context and consequences. When rules are clear but the environment is unfamiliar, let the agent investigate and list assumptions, then confirm the boundary before execution. When failures repeat, evidence conflicts, or the affected scope expands, autonomy should decrease and responsibility should return to a person. The observed Claude Code split is directional evidence from interactive coding sessions, not a universal ratio for every industry. Write decision types and escalation triggers on the card. Do not copy 70 and 20 as fixed operating targets. Chapter recap. First, set delegation depth by reversibility and uncertainty. Second, keep goals, values, and costly trade-offs with a person. Third, define the failures and conflicts that trigger a takeover. Turn expertise into observable responsibility actions rather than a vague claim that an expert is present. A clear task definition names the object, constraints, completion evidence, and prohibited actions. A polished wish is not enough. Write verification before execution, required tests, primary data, comparison checks, and the audit trail that must remain. Expert users correct the agent at pivotal points because they can recognize fluent work that violates the domain rule. The study's strict verified success rate is 15% for novice-rated sessions and roughly 28 to 33% for intermediate or higher sessions. Most of the gain occurs between novice and intermediate. Working competence captures much of the benefit, while deep mastery adds a smaller margin. Experts also recover more often when sessions hit trouble. A responsible workflow needs a recovery path, not only a happy path. Chapter recap. First, encode expertise as constraints and completion evidence. Second, correct pivotal deviations instead of trusting fluency. Third, preserve a path to diagnose, narrow scope, and take over. Put the principles into a 4-field agent responsibility card. Field 1 is the planning owner, who defines the goal, priorities, allowed trade-offs, and completion standard. Field 2 is execution authority, what the agent may read, change, run, and combine, plus actions that remain prohibited. Field 3 is verification evidence, tests, primary sources, diffs, or reproducible commands attached to every consequential result. Field 4 is the failure owner, who takes over after repeated failure, conflicting evidence, scope expansion, or an irreversible action. Fill the planning and failure owners first. Then open execution authority and close the loop by checking each required piece of evidence. This card is a workflow inference from the study's Division of Labor and Expertise signals. The report did not validate this specific card. Chapter recap. First, name the planning and failure owners. Second, grant bounded execution authority. Third, let agreed evidence determine whether the work is done. Domain experts are effective with agents not because they make agents do less, but because they clarify goals, constraints, evidence, and takeover points. Keep the research boundary visible. Success is inferred from transcript classifiers and verifiable signals, not real-world outcomes, and non-interactive usage is excluded. Before the next AI agent run, write 4 fields: planning owner, execution authority, verification evidence, and failure owner. Follow Tiny Agent. Tiny Agent helps you get better at using AI.